Now come back, you can check right click, or you can design and optimize automatically by using Tekla Structural Designer. You can use the option. You can use you can open load analysis review to check the load. Now you can change to the first order analysis. You can change to the chest down or glass chest down, and the axial force. You can refresh loading. Axial force can change to the envelope. Now I use the envelope to check for the maximum load. You can check here. At the bottom is 36.3 kilonewton, and you can check for the measure, and for the minor okay. Now let's come back, click on column again, click on report for member. Can generate report, structural report of this column. Now let's check. This is the report C32 static longitudinal and high summary. This is the summary report of the column. Click close, right click on column again. You can generate drawing. Yes, the scale can use scale 1 to 25 or 1 to 50 or 100. You can change the scale. Click OK, and use AutoCAD. Click OK. Now AutoCAD 2026 just launched application. Let's wait the software as the complete open the drawing or the reinforcement and the formwork of the column C31 will be automatically integrated with AutoCAD. Now let's check here. Okay, now I want to review only. Yes, click close. Now you can zoom in. You see here, this is the section we use 700 multiply 700 millimeter. A is equal to 20. Diameter of rebar is 20 millimeter. A, and B is equal to H 225. The C rebar or link rebar, B and C. Yes, B and C. This one is for the C, and you can count 2, 4, 5, 10, 16. Yes, 16. This section you have 15 multiply with H for the link reinforcement, and you can check for the other yes, for the upper floor. And this is the unit mass, kilonewton per meter length, and total length, total mass of the reinforcement. The bar mark 1, 2, 3, 9, 10. The quantity and the shape and the member. Can you this section and with the summary report of the reinforcement to help you for the typical drawing. For more detail, you can use Tekla. You can use advanced concrete or AutoCAD structural detailing or AutoCAD to make more detail about this column. Now let's come back. Okay, this is the way you can show the result on the element. It the same with the wall. You can use it the same in the wall. You can click on the status. Okay, you can click on wall panel or right click on design to design and optimization, automatic update the section, or check what I want to check. Yes, this is the ratio at the floor. This is the panel 1 2 3. The panel 1 is 0.85. the design ratio. You can check more detail. Yeah, the thickness is 200 millimeter. And the vertical rebar 52 H 97. You can change the diameter of rebar to 10 or to 12 to increase the spacing. The spacing is very low, so you can increase it to 150 or whatever you want. Okay, now I click to check the shear. Yeah, the shear, the ratio. Click close, and again you can click to check the interactive design. Click on the lateral, click on the interaction diagram. Here the apply this one is the critical. Yes, the critical moment. Yes, moment, and the design capacity of the section. So this moment is inside of the design capacity of the section. It's okay. Then check for the additional design cases, lateral, horizontal, check limit, longitudinal, the summary of the design result. You can click on the detail drawing, or you can click on check or auto design panel. You want to automatically design. Now let me detail drawing. Click on detail drawing. I don't want to seal this drawing. Now let's click without sealing. Yes, now you see here, this is for the wall panel. Yes, cross section wall 200 multiplied to 1050. The 200 the width of the section, and the length of the section is 2500 millimeter, and the A is the bar diameter 8 millimeter, and B and C you can check here. B for the horizontal rebar, and C at the corner. Yes, this one is for the C. Now let me move. You can see the shape is like the U shape, and for the A, yes, the vertical reinforcement. This is the layout of the wall. Okay, layout of the wall. You can check at the top. Yes, this is the summary design of the rebar, the marks and tie quality. You can check here. Again, let me come back to the Tekla Structural Designer. You can check for the other member. Use the same Now let me check for the pie cap. Right click, click on check panel. Check panel bearing pressure summary. You can check here the limit is 100 kilonewton per square meter and the max value is 11.6. The status utilization is 0.1. Reinforcement design, top bottom. And you can check for other panel. Okay, capacity, pressure. Now click close. Yes, you can apply it the same concept with the pie cap, with the basement wall, and for the column slab. This is how you can check design in Tekla Structural Designer. Tekla Structural Designer is a good software. Tell you how you can perform your structure, what you should do when your structure is sway or non-sway or twist around direction 1 or direction 2. You can check the design in this table. The tabular table, it is very important for designer to check this the option first to determine what type of structural analysis you should do. You should do a linear analysis, or second order analysis, or non-linear analysis. You can check this data tell you what type of structural analysis you should use. Okay, it is very important. You can see here the C1. This is the alpha direction 1. If I is lower than 10, if you have to perform second order analysis with P data. And Tekla Structural Designer automatically you notional load to apply for the building. You can check in the load combination. It is very good concept. Now let me check in the load combination. Okay, let's draw load cast. Yes, load group, load combination, service. Now the Tekla Structural Designer will you automatically load with the notional load. You have to check. Circuit impose. Now I'm not seeing notional load automatically. You can check it again, because this software is the default option. You notional load include with the combination. Yes, you have to check the alpha. It is very important. And the twist, you can check it. Twist here, when the twist is less than 1 or is equal 1, is okay. The status is pass. And when the twist is over 1, you can check it 1.1 or 1.2 or 1.13. So you can add more wall at the corner to avoid twist on the column. You can click on one column. Now let me check at the column and check detail. You see the warning. The warning alert us first order analysis is not appropriate for this level. So this alpha is 5.33 and the alpha in direction 2 is 6.24. So you must to perform include the second order analysis. Yes, it is very good option. Tekla Structural Designer alert how to choose the correct method to analyze and design. Don't skip this step. When you see the error, when you see the warning, you should to fix and you should to check it. What is the warning? How to fix it? And click on direction 2. Yes, the same for the both direction. And direction 1, 2. Deflection upper, stake high. You can check. Click OK. And come back with the sway. You can click on the sway. You can click on the wind twist. Okay, now let's check for the wind twist. It's okay. Wind twist. See low combination, result 10 deflection, result 10 twist, ratio limit, ratio pass. Now let's click on want to check for monitor. Y is 0, 0. Now let me check the this is the inter storey twist. Seismic, we do not perform the seismic. Yes, not yet designed. The inter storey shear, you can check. This one check for sway or non-sway. Okay. You can check for the materials. The material. What? Why? Concrete, beam, column. Okay, you can check here. The section, the grade, the length, volume, and reinforcement, and embodied carbon mass. You can check to the embodied carbon overview. Yes, you can check group by material or by construction type. Now you can check for the column, beam column. Click it to check for the materials. Okay, we check for the beam and for the column. Cast in place or precast, we use cast in place concrete, and you can export to the Excel. Click on the Excel. Maximize. Okay, the volume of the concrete, the reinforcement, and this one is the total. Yes, we correct. It's the total value. Now let me verify. Yes, this one is the total. Close it. I don't want to seal. Come back to structure 3D. Okay, now we complete analysis and design 17-story building in Tekla Structural Designer. Congratulations for all participants to watch my this tutorial. You know how to model, how to analyze. I show you every aspect of how to model one building, from using the grid or by using copy from one floor to one floor, and you choose which method available for your project. Okay, you can use modeling start from construction line, did everything from here by using add about and using the master story with the similar story, other story. Okay, I want to use the 16 story similar with 18 story. When you model one story, other story will be the same. or you can keep it in the unique. Whatever you want to do, you have to know about your direction or your purpose to modeling and design. Now we complete for modeling, analysis, design, core wall, yes, shear wall, slab, beam, and pie cap with the deep foundation. To reduce the twist, you should to add the wall in this direction. Yeah. Now let me view at the top. So you could add the wall in this in the corner, and add the wall in the corner. So your column will be reduce the twist, or we call the core wall in the location when the wind apply in direction. This building will be twist over here, and when you apply one load direction in the direction, it also not twist, because the structure also twist at the corner. So to correct this concept, you can add the wall panel in the corner, at the corner of this building. Yes, you can add this one corner and this one corner. For the strength is okay, but for the check for the twist, you can to prevent it by at the wall. Now let me show you other one. Click on the review, result review. Now let me click on the review. I want to show the design again, or the beam. Now let's check one beam. Okay, this beam, right click, and you can check for the load. Yes, open load analysis. Okay, and you can change the analysis type, axial, measure, and minor bending. Now check on the measure and show the redux. You can turn it on or turn it off. Span whole beam, you can change on the one beam, one span. Now let me change on the one span or two span, or you can click on the whole beam to be down 1 2 3 4 and 5. Yes, 1 2 3 4 5. You can show the 1 2 3 4 5, or you can show the whole beam. Okay, go down, show loading. You can show loading. This is the loading apply on the beam. And show shear. This is the shear. The maximum shear at the support is 56.6 kilonewton, and at the support minus 77.2 kilonewton. And the show moment, you can show the moment, show deflection. Relative, this is the relative deflection. Yes, 2.5 millimeter, 4.5 millimeter, 8, 0.8, 0.5. So dimension, yes, dimension. You see here dimension. And so extreme. So extreme value. The extreme value is the maximum value on its span. Okay, its span, the maximum value is 56.6, and at the bottom is minus 75.2 kilonewton. And you can change for the load combination. Now let me click on envelope to check for the envelope. Yes, you see here, it's either envelope all load combination. Yes, one you check one load combination, 2 second, third, 4. So when you use the envelope, this is the maximum all the load combination. Yes, and check here, and you can refresh workspace. Now let me check. You can close, or you can add horizontal type group. Okay, now let me close. I don't want to show it more. Now let's show you about the pie cap. Now I want to show you this pie cap, and check for the member. You see here the property pie cap one item. Check for the member. Yes, the pie cap, the apply load summary, the moment, the apply force, pi axial capacity, the P max maximum is 12.1 kilonewton, and the ratio is 0.571. You can check for the summary, bending capacity. Yes, and you can check for the shear, one-way shear, limiting parameter. Now let me click on this one and click on expand, collapse all. Yes, expand all. Yes, expand all. You can check it. Now click close and click on it again. Click on pi. I want to check pi. Right click on check member. Yeah, so you for the pi, more pi. Okay, now complete for the checking or the member or the made function or the pi cap, more pi, basement wall, column, beam and slab. Now let me show you how to view this beam. Now let me click on this beam. Yes, let me click on one beam and right click. You can add to substructure. Okay, you can add to substructure. Now let me come back to the view. Okay, again click one beam and right click. Add to substructure. Okay, you can add to substructure. Or you can edit this member by add the size in expand. Okay, you can edit new section on expand. This beam 1 2 3 4 5 6 7 span. Okay, now let's check it's correct or not. 1 2 3 4 5 6 7 is correct. Okay, again click on this icon again, and reinforcement. You can change reinforcement or release or expand, nominal cover or expand, analysis and control design parameter, fireproofing. If you want to use, you can use a protect to use a fireproofing on this beam. And tick it, click OK. Now let me show none. Okay, and you can show to view, you can show view for the report. Now let me show 2D on the second floor and click it to the 3D. Okay, you can show it. Yes. Thank you for your watching. I hope you enjoyed this tutorial. Please subscribe my YouTube channel to get new tutorials about the building, the warehouse, and other special structure we will really soon. Thank you. I hope you enjoy.